Hello to all of you, this is Dr. Dhaval Maheta and today we will understand how to run independent sample t-test using Python for unstacked data. So in case of independent sample t-test, we are comparing two groups, that is group 1 with group 2. Participants of both this group are different. The null hypothesis is there is no significant difference in means of two groups. Basically, we are comparing the means of two groups, that is means of section A with means of section B, mean of process A with mean of process B, mean of department A with department B. There are only two groups for comparison. Now after this, we will have to understand the concept of stacked and unstacked data. Now, in this case, section is kept in one column and marks are kept in another column. So section A, and B, and the marks are kept here. So this is a stacked data. Please refer my previous video in which I have discussed how to run independent sample t-test on stacked data. In this video, I'm going to discuss how to run it on unstacked data. So now the same thing I can represent in this format. Section A and its marks. You can see 45, 34 and 23. Section B and its marks. So in this video, I'm going to talk about unstacked data. So for this, we will have to go in Jupyter Notebook. Now import pandas as PD, import numpy as np, from SkyP import stats. Now teacher is equal to pd dot read underscore csv. R we are using for smooth import of the data file. Then I'll run teacher dot head round bracket. So teacher 1, teacher 2 and teacher 3 and the marks of the students are there. Now first of all, in case of independent sample t-test, we have to run Levin's test. The null hypothesis of the Levin's test is two groups have equal variances. The alternative is two groups does not have equal variances. We'll be running Levin's test. The command line is stat, p is equal to stats.levin teacher.t1. Teacher is a data frame .t1, teacher.t2, this one. Everything else remains same. I'll request all of you kindly refer my previous video to understand the flow of this series. So print statistics is equal to percentage dot 3 float. 3 float means generate the output in 3 decimal. P is equal to percentage dot 3f. Alpha is a 5% level of significance. So if the p value is greater than alpha, we fail to reject null or we say that the distribution is same. Else the distribution is different. So here you can see the p value is more than 0.05. We fail to reject null, which means that the distribution of two groups are equal. Quite good. So the assumption in case of independent sample t-test are two assumptions are there. One assumption is that the data should be normally distributed, and second, the variances of these two groups should be equal. Now we are in the position to run the independent sample t-test. So here we will be running stat, p is equal to stats dot t-test underscore independent teacher.t1, teacher.t2. So the null hypothesis is there is no significant difference in marks according to the teacher 1 and teacher 2. Alternative is there is significant difference in marks according to the teacher 1 and teacher 2. So we have written this command line. This remains the same as we have written it here. So instead of distribution, it will be means of two groups are equal. That is, we fail to reject HO. Else, if this value is less than 0.05, we reject null, which means that means of two groups are not equal. You can see here the value, this value is less than 0.05 and we got the answer, that is means of two groups are not equal. So for more videos on data science using Python, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I have already uploaded many videos which are related to data science using Python. Please don't forget to subscribe my channel and like the video.